By the end of this lesson, you will be able to compute the four most common measures of variability: the range, the interquartile range, the variance, and the standard deviation. In addition, you will be able to describe what happens to measures of variability when you make global changes to a data set. The first measure of variability that we will discuss is the range. The range is the difference between the largest value and the smallest value in a set of values. For example, consider the following set of values: 2, 4, 9, 5, 7, 3. What is the largest number in our data set? The largest number is 9. And what is the smallest number? The smallest number is 2. So the range is the largest number minus the smallest number, or 9 minus 2, which equals 7. As a measure of variability, the range has advantages and disadvantages. The main advantage: it is easy to calculate. The main disadvantage: it relies on only two values, the largest value and the smallest value in the data set. The range ignores variability in all of the middle values. For example, look at data set A. The range of data set A is equal to the largest number in the data set minus the smallest number in the data set, or 9 minus 1, which equals 8. Compare data set A to data set B. All of the numbers in data set A are different, whereas in data set B, all of the numbers except 1 are the same. In short, data set B has much less variability. Despite these differences in variability, the range of both data sets is equal to 8. This example illustrates how the range can be deficient as a measure of variability, because it considers only the largest value and the smallest value in a data set. It ignores variability in the middle values. The interquartile range is a measure of variability that does not ignore the middle values. The interquartile range is based on dividing an ordered set of data into 4 equal parts called quartiles. The values that divide each part are called the first, second, and third quartiles. These quartiles are denoted by Q1, Q2, and Q3, respectively. Here's how to find the interquartile range. First, arrange the data set in numerical order. Then define the quartiles. The second quartile, Q2, is the median of the entire data set. The first quartile, Q1, is the median of data below Q2. The third quartile, Q3, is the median of the data above Q2. And finally, the interquartile range is equal to Q3 minus Q1. Let's work through an example using the numbers from 0 to 9. Step 1 is to arrange these numbers in order from smallest to largest. Then we find Q2, which is the median of the entire data set. Recall from the previous lesson that when you have an even number of values, the median is equal to the sum of the middle two values divided by 2. So in this example, the median, Q2, is equal to 4 plus 5 divided by 2, or 4.5. Then we find Q1, which is the median of all the values below Q2. So Q1 is the median of 0, 1, 2, 3, and 4, which equals 2. And finally, we find Q3, which is the median of all the values above Q2. So Q3 is the median of 5, 6, 7, 8, and 9, which equals 7. Now that we've defined Q3 and Q1, we can compute the interquartile range as Q3 minus Q1. In this example, the interquartile range is equal to 7 minus 2, or 5. Notice that the interquartile range is not affected by outliers. If the largest value had been 999 instead of 9, Q1 still would have been 2. Q2 still would have been 4.5, and Q3 still would have been 7. And the interquartile range would still have been 5. So if you were asked to describe the difference between the range and the interquartile range, you might say that the range is strongly influenced by outliers, but the interquartile range is not. Variance is the average squared deviation from the mean, and it can be calculated from the following formula. The notation used in this formula shows up again and again throughout this course. Variance is represented by lowercase sigma squared. Capital sigma is the summation symbol. X sub I stands for the ith element in the data set. Mu is the mean of the data set. And n represents the number of elements in the data set. The term sigma x minus mu, all squared, is called the deviation sum of squares. We saw this term in the formula for variance, and it shows up in other formulas in statistics. Let's work through an example. We want to find the variance of 4 numbers, 0, 1, 5, and 6. We will use the formula for variance, which is, to compute the variance from this formula, we need to know several things. First, we need to know the value for n, the number of values in the data set. We have 4 numbers in the data set, so n equals 4. Next, we need to compute the mean, which we learned to do in the last lesson. The mean is equal to the sum of values divided by the number of values. And finally, we need to compute the deviation sum of squares, which is the numerator of the variance formula. So, before we can calculate the variance, we need to compute the mean and the deviation sum of squares. So let's do that. Recall that the mean is equal to the sum of values, sigma x, divided by the number of values, n. Thus the mean is equal to 0 plus 1 plus 5 plus 6, all divided by 4, which equals 12 divided by 4, or 3. Given the mean, we can compute the deviation sum of squares. We see that the deviation sum of squares is equal to 0 minus the mean 3 squared plus 1 minus the mean 3 squared plus 5 minus 3 squared plus 6 minus 3 squared. This turns out to be 9 plus 4 plus 4 plus 9, or 26. Finally, we have everything we need to compute the variance. Variance is equal to the deviation sum of squares, 26, divided by n, 4, which is 6.5. If any of this is unclear, please pause the video and review the computations until you understand how to calculate the variance. Once you understand variance, the standard deviation is a piece of cake, since the standard deviation is simply the square root of variance. So to find the standard deviation of a set of data, you would compute the variance and take the square root. Let's work through a couple of examples. If the variance of a set of data was 100, what would be the standard deviation? Since the standard deviation is the square root of the variance, the standard deviation would be the square root of 100, which is 10. If the standard deviation were 4, what would be the variance? Since the standard deviation is the square root of the variance is the square of the standard deviation. So if the standard deviation were 4, the variance would be 4 squared, or 16. And finally, notice how notation is consistent with definitions for the standard deviation and variance. The symbol for variance is sigma squared. The standard deviation is the square root of the variance, so it makes sense that the symbol for the standard deviation is sigma, the square root of sigma squared. If you take the Advanced Placement Statistics exam, you will be expected to know what happens to measures of variability when you add a constant to each value in the data set. Think about it. What would happen if you added a constant, like the number 5, to each value in a data set? How would measures of variability change? Well, if you add a constant to every value, the distance between values does not change. As a result, all measures of variability, the range, interquartile range, variance, and standard deviation, stay the same. For advanced placement statistics, you are also expected to know what happens to measures of variability when you multiply each value in the data set by a constant. The range, interquartile range, and standard deviation are also multiplied by that constant. But the variance is multiplied by the square of the constant. Suppose dataset A is described by the following measures of variability: a range of 9, an interquartile range of 5, a variance of 4, and a standard deviation of 2. How would measures of variability change if you add 10 to every element in dataset A? If you add a constant to a dataset, the difference between values does not change. So the measures of variability don't change. Therefore, even after you add 10 to dataset A, the range is still 9, the interquartile range is still 5, the variance is still 4, and the standard deviation is still 2. How about if you multiply every element in dataset A by 3? What would happen to the measures of variability? When you multiply the elements of a dataset by a constant, the range, interquartile range, and standard deviation are also multiplied by that constant. So if we multiply every element in dataset A by 3, the new range would be 9 times 3, or 27. The new interquartile range would be 3 times 5, or 15. And the new standard deviation would be 3 times 2, or 6. The effect on variance is a little bit different. Multiplying every element in a dataset by a constant multiplies the variance by the square of the constant. So in this example, the new variance would be 4 times 3 squared, or 4 times 9, which is 36. Again, if you are planning on taking the Advanced Placement Statistics exam, please be sure you understand how measures of variability are affected when a constant is added to a data set or when a data set is multiplied by a constant. These are topics that may show up on the exam. Let's review. This lesson has been all about measures that describe variability in a set of data. We described 4 measures: the range, interquartile range, variance, and standard deviation. The range is the largest value minus the smallest value. The range is easy to calculate, but it ignores middle values and sometimes is influenced too much by outliers. The interquartile range is equal to the third quartile minus the first quartile, and, unlike the range, is not influenced by outliers. The variance is the average squared deviation from the mean, and is denoted by sigma squared. The standard deviation is the square root of the variance, and is denoted by the lowercase Greek letter sigma. And finally, we described how measures of variation are affected by global change to the data set, like adding a constant to every value in the data set or multiplying every value by a constant. Adding a constant has no effect on variability, so the measures of variability are unchanged. However, multiplying a constant does affect variability. The range, interquartile range, and standard deviation are also multiplied by a constant, and the variance is multiplied by the square of the constant.